So when we're doing optimization problems, we need to come up with an equation to optimize. So this graph here gives us points, this little rectangle here, and it gives us points at 0, 3, 0, x 0. Okay, so these points here and here, and it gives us a point at x and on the curve 1 over x squared, and it gives us another point here, and it wants to know how to maximize this area based on the fixed point of 3 and that movable point x. So as we move that x around, it's going to make a different rectangles with different areas. So the first thing we do is we want to come up with an equation that maximizes the area. So the area that is in question is going to be the area is equal to length times width. So in this context, it's going to be the length is going to be the difference, the width here. Okay, that's going to be the difference in the coordinates x and 3. And then the height is just going to be the y coordinate of that graph, which is 1 over x squared. Now, in this case here, we only have one variable to worry about. So we have an equation that we can differentiate to find where the max and mins are. Okay, so this is the first thing. I need to come up with an equation to maximize the area. I need to write it in terms of the variables. And if there's extra variables, we're going to have to do some elimination of variables. We'll be able to write some of the variables in terms of other variables just so that we have a function in terms of x. So in this case, we have a function in terms of x, and we don't have to worry about any extra variables. Okay, so here's our equation that we need to maximize. So I want to maximize this, so I need to differentiate, and I want to find where the derivative is equal to 0. So first thing is differentiating this. So I end up with x squared minus, so I'm using the quotient rule here, minus x minus 3 times the derivative of x squared is 2x. Okay, so this should be 1 here. The derivative of x minus 3 is 1. And that's all over x to the power 4. So there's my quotient rule. So a prime of x is equal to x squared minus 2x squared plus 6x. So I'm going to simplify that expression. So a prime of x is equal to 6x minus x squared. I should factor the x out and simplify this expression. So this expression simplifies to 6 minus x, all divided by x cubed. So there's my derivative. I want to solve this derivative equal to 0. When I solve this derivative equal to 0, I get the solution x equals 6. Okay, so I don't worry about the denominator. As long as x is not equal to 0, I know that's a valid solution. So for what x value does a rectangle have a max area? So if I draw this same picture, and basically the picture that's drawn here is a maximum area. So that looks like about 6, and that rectangle is going to be bigger than any other one I can draw. So for example, if I have a point here, that rectangle I can draw is definitely a smaller area. Point over here, the rectangle I can draw here is definitely a smaller area. So that blue rectangle looks like it's putting the coordinate at about 6, and that gives us the max area. Okay, and furthermore, we can actually calculate the max area by going back to the a of x equation and plugging in 6 into that equation, and we get an area. In this case, it looks like it's 3 over 36, or the area is 1 over 12 units squared.